Good morning, one and all. Today I am going to explain about my concept video, and our topic is Laplace transform to employ in the first shifting theorem. And my name is Laplace, and my roll number is 20951021005 as shown on the screen. And I am related to the aeronautical engineering of the branch. And our topic is related to the mathematical transform techniques, which is generally known as MTT. First of all, you have to know definition of Laplace. Let f of t be the given function and defined for all positive values of t. Then the Laplace transform of f of t denoted by L of f of t or f power of s is defined by L of f of t equals to f power of s equals to integration of 0 to infinity e power minus st into f of t into dt. Provided the integral exists, the parameter s is real or complex. First shifting theorem. We know that first shifting theorem, if L of f of t equals to f power of s, then L of e power at into f of t equals to f power of s minus a. We can identify that in the presence of e power at, a is the positive, so we get that s minus a, where s minus a should be greater than 0. If e power at into t power n equals to t power n to s minus a, when factorial by s power n plus 1 changes to s2 s minus a, and we get the power of the result n factorial by s minus a into n plus 1. Second one, e power at into sin bt. L of sin bt gives us to s of a minus a. In the presence of e power at, it is positive, so we get that s minus a. So in generally known as sin bt formula is b by s square plus s square, b by s square plus b square. In the place of s, we can write that s implies that s minus a, and substituting in this equation, we get the overall results. We find L of e power minus t into cos square t, given L of e power minus t into cos square t. L of cos square t, according to trigonometric forms, we can write that L of 1 plus cos 2t by 2. Applying the Laplace equations, and by using the linearity property, L of c1 into f of t plus c2 into g of t equals to c1 into L of f of t plus c2 into L of g of t. You can write L of 1, you can write as 1 by s plus L of cos 2t by s square plus 4, and we get overall the result s square plus 4s plus s square by s into s square plus, and then we can cut the result to s square plus 4 by s into s square plus 4, and we get that s square plus 4 s square plus 2 by s into s square plus 4. Using the first shifting theorem, if L of f of t equals to f bar of s, then L of e power minus at into f of t, then we get that in the above equation there e power at is a minus, so we can consider that f of s plus a. In there is minus, we get in the below equations plus, so that s plus a is greater than 0. L of e power minus t into cos square into dt. L of cos square t in the presence of e power minus t, it is negative, so it implies that s plus 1. According to the trigonometric equations, we get that further equation s square by s into s square plus 1. In the s implies that s plus 1. Substituting these equations, we get the overall the result is s plus 1 whole square plus 2 by s plus 1 into s plus 1 whole square plus 4. And the overall equation, we get that s square plus 2s plus 3 by s plus 1 into s square plus 2s plus 5. And according to first shifting theorem, we know that L of f of t equals to f power of s, then L of e power at into f of t equals to f power of s minus a, where s minus a should be greater than 0. In the equation here, e power at is a positive, so we get that the below equation negative. L of e power at into t power n gives us to t power n into s implies to s minus a. In t power n formula, we have to know that generally in factorial by s plus s power n plus 1, changing s to s minus a, we get the equation in factorial by s minus a into n plus 1. L of e power at into sin bt. L of sin bt. In this equation, a is a positive, so we get implies that s to s minus a. Generally known as the sin bt formula is b by s square plus b square. S implies s minus a. In substituting in this equation, we get the overall the results, that is s square plus 2 by s into s square plus 4. Then again using the first shifting theorem, L of f of t gives us to power of s. Then L of L into e power at into f of t gives us to s plus a, where s plus a should be greater than 0. By using this equation here a is a negative, so we get that as positive. L of e power minus t into cos square t is raised to L of cos square t into, in the place of minus we have substituting s plus 1, s square plus 2 by s into s square plus 4. And substituting in this equation, get overall the results. Thank you for giving this opportunity.